When it comes to determining angles, that becomes a little bit more challenging. As x is to algebra as an unknown, the Greek symbol theta, in North Shore we say theta. So that is just the unknown angle. I can place theta in either location. Some people write this as theta 1, theta 2, or they use theta and another symbol. All we need to know is when we're looking at a triangle and they start to define the functions that you use to solve for an angle based on the proportions of the sides, you start to look at the different trigonometric functions. But the first thing you want to get under control is the fact that when you're looking at a triangle, and if the angle down here is the one you're solving for, the theta, you have to first establish and understand which side of the triangle is the side opposite to the angle you're investigating. So if you stand here and look out, the fence line is here, you got to look this way, that's the opposite side. If you take a bow and arrow and you shoot it, you're going to hit the opposite side. So this is always the side opposite to the angle. So what if we're looking over here? Well, then that's the opposite side, because it's the side opposite to the angle. So this moves around based on the angle you're looking at. Do we ever use this as theta? No, it doesn't work. The only reason it doesn't work, or one of the reasons it doesn't work, math people don't jump all over me here, that is an opposite side. That is also the hypotenuse. Okay. The problem is, which one is the adjacent? Because they're both next to the angle. So, no. We look at theta as being here or here. So if we go back and say, hey, that's the opposite side. This is always the hypotenuse, so that never changes, longest side. So if you got this side and you know where that is, well, that doesn't leave you much choice. The adjacent's over here. Adjacent means next to. So within the vertex here, you have a hypotenuse and the adjacent. Opposites hanging out over here. Long and short of this is, if you want to figure out how many degrees these vertices or this arc length would be from here to here, they came up with the trigonometric relations that will say if you have certain sides on a triangle, certain proportions, then you will always get specific degrees related to those proportions. And so what happens here is, because we have three sides, we have a possibility of three different ratios. And they've defined the first relationship is if you want to figure out what the sine of the angle is. The sine is defined as if you take the length of the opposite side and you divide it by the hypotenuse, so the ratio of this divided by this, you'll get a number. The number will never be greater than 1. And it turns out that each ratio of these numbers, 0.1, 0.2, 0.3, 0.4, and these numbers go out to 4 decimal places. Each one of those is equivalent to a particular degree or fractions thereof. And if you know these two sides, you can get this angle using the sine function. If you don't know this side, but you know these two, well, guess what? The cosine will let you solve for that. And the cosine is designed so that if this triangle has a specific proportion, if the sine gave you a certain number of degrees here, say it's 30 degrees, if you do the cosine of these two, this is going to give you 30 degrees also. Because we're looking at two different sides, two different ratios. The tangent lets you come at this angle from another view. So because you can have 3 ratios of sides, there are 3 possible relationships, trigonometric, that will let you get the answer for this angle. So 3 possibilities for getting the same angle. That allows the greatest flexibility due to the ratios. And all we're doing is figuring out what do these two legs, when one's divided by the other, what does this represent in terms of a particular angle on a triangle? So we're taking a decimal value and converting it to degrees. That's the long explanation. The challenging part is, if you've never done this before, you hit this in physics, is how do you solve for an angle when you only have sides to work with? And I want to go over that. If I go back here and let's make things easy. Let's say that I have a triangle and this side is 6 and this side is 12. I have a hypotenuse equal to 12 and I have an opposite side equal to 6. And say I don't know anything else. Say this is unknown down here. We don't know. So x equals, or a equals. I can figure out this angle knowing 2 sides out of 3 because I have a function that says if you know 2 of these sides and you realize it's a sine function, you can solve for that angle. The tricky part is knowing how to write this out so you demonstrate that you understand what's going on with the operation. So if I was going to lay this one out and say that if I have a triangle like this, and I'm in detail here and I say the sine, now notice what I'm doing. The parentheses for me is going to indicate you're performing an operation. So it's not sine times theta, it's the sine of theta. So the sine of this particular angle is equivalent to the ratio of the opposite side over the hypotenuse. So I start to abbreviate these things because you can also write this as either SOH or SO. And people are taught either SOHCAHTOA, where this is the sine. Sine is opposite over hypotenuse. Cosine CA is adjacent over hypotenuse. And tangent TOA is opposite over adjacent. So just a shorthand way to remember those. I need to solve for theta. So I'm just going to say, well, the sine of this angle theta is defined as the ratio of the opposite to the hypotenuse. So 6 over 12. Now this is where you really got to pay attention. This 6 over 12, if you could look it up on a sine table, old school style, it would tell you that this equals 30 degrees. Because if you just read the numbers down, 6 over 12 is 0.5. And so we have a calculator now that has these tables stored in them. And it allows you to calculate any particular degree for any particular ratio. Now this is not the angle. This is the sine of the angle, which is the ratio between 2 sides. To get the angle by itself, and I know this is going to be incorrect because I've talked to one of my colleagues who's a math teacher that says, no, you're not doing that. Well, I'm doing it, so hang on. I'm saying you're performing an inverse operation, so you're effectively isolating the theta by doing this. You're going to take the inverse sine of both sides. Now notice what I'm doing. I'm performing an operation on an operator, but I'm doing this to both sides. And notice what's going to happen here. The way I'm doing this is I'm showing you the fact that I'm operating on this and I'm operating on this. It's not the inverse sine, which is written as sine to the minus 1, times that. It's not multiplication. This has to operate on a number, on a value. This is going to allow you to say that I want to know what the degree symbol is. So when you take this inverse operation, you're saying that I don't want to know the sine of theta. I want to know theta. I want to know the angle. And when you do the inverse sine, now if you haven't done this on a calculator, let me kind of go over this with you. With the Casios at least, you have to go to the second row of buttons. So with the Casio, you're doing shift, and if you look along the row here where there's a sign, right above it there's a small yellow fonted sine minus 1. So it means I'm going to be taking the inverse sine of a particular value. I don't have to do the left-hand side. This is just saying this is now what x equals. I need to do the inverse sine of this side. And while it's not absolutely necessary in most cases, I'm going to bracket this to let this thing know I want to take the inverse sine of this number right here. and then I hit EXE, and I get 30, and it's 30 degrees. So when we do things in physics, we are going to use degree measurement, which means you have to make sure the angle measurement mode in your calculator is in degrees. And it will say usually on the front screen either DEG or RAD. RAD is radians. You have to go to the menu and reset that. This is how you would do any trig function using the inverse of the trig function to get the angle. They're all done the same way. So I could have done this with the inverse cosine or the inverse tangent. And you're always going to get the same answer. If we focus on this and we know these three sides, no matter what I use, tangent, cosine, sine, the ratios are always going to give 30 degrees here for these particular proportions, if I knew what this one was. I hope that has helped. Have a good night. And bye-bye.